And I'm going to share my camera with you. So have your science notebooks open. And what we're going to be looking at today there we go. What we're going to be looking at today, I'm in class. What we're going to be looking at today is how we can identify a variable from a testable question. We want to look back at our notes from yesterday. We want to remember that an independent variable is a variable that you make changes with. You have the control to change, and it's what makes everything different. A dependent variable, that's our ending result. That's what's changed because of our independent variable, and our controlled variable or constant variable, that's the variable that doesn't change, it stays the same. We want to remember our two C's. The controlled variable, here we go. The controlled variable compares the results. Okay, that's why we keep something the same. At the top of our papers today, I want to make a key. So we'll need two different colors. Okay, I'm going to use yellow and pink. You don't have to use the same colors as me. Anything I highlight in pink is going to be my independent variable. We want to remember that's how Ms. Neville abbreviates independent variable, capital I-V. And anything I highlight in yellow is going to be my dependent variable. So in your notes, you should have written identifying variables for each testable question. That's all you need to have in your notes there. I'll underline it so you know what you need to have. And in your notes, if we were in class together, you would already have this sheet. But in your notes, you're going to write these top 3 questions in your notes, okay? So let's start with our first one. Move it up so you can see it. Number 1, how does this is a testable question. Remember, this is a question that we can use to, that we're testing using an experiment, okay? So the testable question is, how does the distance from an eye chart affect the number of letters that are recognized on a line? So I've got to think about here. I'm going to get my pink first. Here we go. So I've got to see here what's going to be changed in this testable question. What's going to make everything different? Does anyone want to turn on their mic and make a guess? What are we actually changing here? The distance from the eye chart, that is my independent variable. The distance from the eye chart is my independent variable because I have control over changing that. If I go closer to that chart, I'll probably be able to see more letters. If I go farther away from that chart, I'll be able to see less letters. So that's my independent variable. Now let's talk about my dependent variable here. With our dependent variable, that's our ending result. So because I can move farther or closer to that eye chart, it's going to change the number of letters that are recognized on a line. That is my dependent variable, my ending result. Okay? We want to remember that our independent variable is what makes everything different, what we have control over, and the dependent variable is our ending result. So after I make the change using that independent variable, what will happen? Okay, let's look at example 2. You'll want to write this question in your notes as well. How does the amount of light affect the growth of the plant? Now, someone make a guess here. You may turn on your mics. Let me know, what is my independent variable here? What do I have the power to change here?
The amount of light.
The amount of light is going to be my independent variable. The amount of light is my independent variable. So what is my ending result? Because I changed the amount of light, someone turn on their mic and let me know what's going to be affected.
The growth of a plant.
The growth of the plant is my dependent variable. Remember, we made that key up top. Anything I highlight pink is my independent variable. Anything I highlight yellow is my dependent variable. Let's do one more of these together. How does the amount of oxygen, oh, you probably can't see that, sorry. How does the amount of oxygen in the water affect the oyster population? So we want to remember an oyster is a mollusk that lives in the ocean. And so when we're talking, they're cousins to the clam. How does the amount of oxygen in the water affect the oyster population? That's what a scientist is testing. That's the question his experiment will answer. So once we've written that question down, how does the amount of oxygen in the water affect the oyster population? So what do we have control over in the experiment? Someone turn on their mic and let me know. What's
the amount of
make
oxygen.
everything different? Say it again.
The amount of oxygen.
The amount of oxygen is going to be my independent variable. And so what's going to change? What's going to be my ending result based on the amount of oxygen?
The oyster population.
Yeah, the oyster population is either going to increase or decrease. What do you should notice that word affect is super important. The dependent variable is always going to come after that word affect. And the independent variable is always going to come before the word affect. The independent variable comes first. Our dependent variable comes last. Okay? So that's going to move us right into our next discussion of what we need to be talking about today. Okay? Let's stop sharing that screen. You may put your highlighters away. You won't need them anymore. You'll still need your science notebook and pencil because we're going to transition right into still talking about the dependent and independent variables, but we're now going to go right into the conversation of plant tropisms, how plants respond to stimuli. And that goes right into a really great conversation about variables, dependent and independent variables. So in our notes, you should be able to see a blank PowerPoint slide here. And I'll be talking about plant tropisms or responses to external stimuli. So we want to pay some key attention here. In our notes, we want to write plant tropisms
and variables. Okay? We want to remember, I don't remember how much of tropisms we talked about, but if we have talked about them already, this is a really good review. If we haven't, you need to make sure you're paying close attention here. Okay? We want to remember that that word tropism means response. Whatever you see Miss Neville writing down, you'll want to write down as well. So there are 4 different types of tropisms. If you remember, phototropism, hydrotropism, gravitropism, and thigmotropism. So let's look at that first one, phototropism. Phototropism talks about, so we'll want to draw a picture here, a plant's response to light. You'll remember you watched a really cool YouTube video on this, that a plant stem will bend towards light. Okay? Phototropism is a plant's response to light. Okay? And that plant's actually going to bend. Okay? So when we're looking at this, so as we look at this, a plant's response to light, it happens by bending. What we'll see here, guys, with phototropism, someone turn on their mic and let me know, what would make everything different? What would make everything different here with phototropism? What would be our independent variable?
The sun.
The light. Yep. Direction to the light. Okay, that direction of light is going to be my independent variable. And what would be my dependent variable then? What would be my ending result, my outcome? What is the plant going to do in the direction of light?
Photosynthesis.
Not only that, but with phototropism, what's that plant stem going to do? Bend to it. So that's our dependent variable here. The plant bends. Okay? So as we're talking about this, one of your questions that you'll have tomorrow is where you're going to have to identify the IV and DV in all 3 of these other tropisms. You may have to go back and look at some older notes. I'll make those notes available for you in the orange folder if you've forgotten them. And what we're going to be able to see here, what we should be able to identify is the independent variable in each of these tropisms and the dependent variable, how that plant responds. Okay? So let's talk about what you should be doing today.